Today's lesson is Module 2, Lesson 16, Even and Odd Numbers. The very first thing I want you to do is open up your student book to page S74, Lesson 16. You'll see the title, and it starts right off with opening exercises. I want you to pause your video and get with a partner and answer the questions that are on this front page, and then come back to your video and we will discuss. Okay, so let's go over what you and your partner have discovered. You should have described an even number as any whole number that ends in 0, 2, 4, 6, or 8. It also can be described as any number that can be divided by 2 evenly, so no remainder or decimals, and all multiples of 2. So if you skip counted by 2s, any of those numbers will be even. Some examples are 2, 4, 6, 8, 10, 12, 48, 70,208, etc. So as long as you wrote a number that ends in one of those digits, 0, 2, 4, 6, or 8. The next question says, what is an odd number? Well, an odd number is any number that's not even. So we could describe it as any whole number that ends in 1, 3, 5, 7, or 9. Any number that cannot be divided by 2 evenly. All numbers that are not multiples of 2. So for example, 1, 3, 5, 7, 9, 11, 376,241, etc. And finally, this last question, it was more of a just try it and see. So the question says, what happens when you add two numbers that are even? So I just tried 3 different ones, and you might have tried others that I didn't try, and that's okay. And you should have concluded that yes, you will always get an even number when you add 2 even numbers. Let's go ahead and go on to the next page. We're going to do exercises 1 through 3 together. There are no examples in today's lesson. So it says, why is the sum of two numbers even? Think of the problem 12 plus 14. Draw dots to represent each number. So I'm just going to there's my 12. There's my next set of 12. And then it says, circle the pair of dots to determine if any dots are left over. So I'm just going to connect the top and bottom rows. And you can see that there are no leftovers. Is this true every time? Well, since 12 is represented by 6 sets of 2 and 14 is represented by 7 sets of 2, the sum is 13 sets of 2. So this is true anytime we add 2 even numbers together, there will never be any leftovers. So we say, yes, this is true every time because with any even number, you can make groups of 2. Sorry, I'm covering up the answer. With no leftovers. Now let's go on to the second question. The second question says, why is the sum of 2 odd numbers even? So this time we're going to draw dots to represent 11 and 15. And then it says circle the pairs. And I've circled all the pairs that are one over the other one, but you can see in this odd number and in this odd number, there's one left, but I can connect those two together. So it says, is it true every time two odd numbers are added together? And we will say, yes, this is true every time because with each odd number, there will be one left, and they can be combined to make a pair. So now let's go on to exercise 3. It says, why is the sum of an even number and an odd number odd? So they want us to draw dots to represent 14 plus 11. So I have 14 here and 11 here. And I will circle each set or each pair. And you see that there's this one left over. So is this true every time an even and odd number are added together? Yes, because with the even number, there will always be pairs, and with the odd number, there will always be a leftover. So it says, what if the first add-in is odd and the second one is even? Is the sum still odd? So if we have 11 and 14, you can see that it will give you the same result, because we know it doesn't matter which order you add numbers, you get the same result. So we can say it doesn't matter the order you add numbers, you get the same result. And that's commutative property of addition that tells us that. Just like we can multiply in any order, you can add in any order, and you will get the same outcome. So to sum it up, we can say that even plus even equals even. Odd plus odd equals even. And even plus odd equals odd. And we can reverse this. Odd plus even equals odd. And I want you to add this, let's sum it up to your notes. So let's go ahead and take out our notebook real quick. And let's just put that in our notes. So Module 2, Lesson 16, even and odd. And we're just going to basically put that information in here. Even plus even equals even. Odd plus odd equals even. We will say even plus odd equals odd. And odd plus even equals odd. And we will call this addition. And the reason why we mark that addition, because in just a minute, you and your partner are going to explore multiplication and determine the rules for when multiplying odd and even numbers. So go ahead and go back to your student book, on to the exploratory challenge. And I want you to go ahead and pause your video and get back with your partner. And I want you to answer 4, 5, and 6, and then come back to your video. So your examples might not match my examples, and that's okay. You can still check your work. So the example I did was 4 times 2. And remember that this multiplication symbol means groups. So 4 groups of 2 is the same as saying 2 plus 2 plus 2 plus 2. So I made 2 dots, 2 dots, 2 dots, 2 dots. And when I grouped them together, there was nothing left over. So I discovered that even times even equals even. On the next one, I did 3 times 5 so that I have 2 odd numbers. And again, that X means groups of. So 3 groups of 5. So 5 plus 5 plus 5. So I made sets of 5. I was able to group 2, and then I had to connect this leftover one to this next group. And then 2 and 2, and then 2 and 2, and then I had 1 left over. So since I had a leftover, I know my answer would be odd. So an odd times an odd will give me an odd answer. And then finally on the last one, it's an odd times an even. So I did 3 times 4, which gave me 12. And again, 3 groups of 4, so that's the same as 4 plus 4 plus 4. I made sets of 4, and then I grouped them in 2s, so there were none left over. So I know that an odd times an even equals an even. And because, again, of commutative property of multiplication, an even times an odd equals an even. So go ahead and take out your notebook and let's add that to our notebook. And we will say even times even equals even. Odd times odd equals odd. And then even times odd equals even. And odd times even equals even. And some of you might be thinking to yourself, well, what do I need this for? This is a good way to check if your answer is correct if you're multiplying. If you know you're multiplying 2 even numbers and you get an odd answer, you know that you made some type of calculation error. So this is just a good reference. Now to complete this lesson, you and your partner can do the problem set together. This top part, this summary, is what we put in our notebook, but it's right here also for you to use to answer the questions in the problem set. All you need to do, you don't have to get any solutions. All you need to do is tell if the answer would be even or odd, and that's it. That's all you have to do. And you'll do the same thing on the exit ticket. If you have any questions, make sure that you come and see me.